So today we are going to discuss the transfer of energy in thermal energy stores of the system or the particle of the system. There are basically three mechanisms via which thermal energy can transfer across the particles of the system or from one system to another. The first kind of mechanism is called conduction, and this mechanism is more prominent in kind of materials that are called solids. Okay. Similarly, the other kind of mechanism that via which the heat energy transfer is called convection, and it's common in fluids, that is liquids and gases. Okay. And the third type of mechanism of energy transfer is a bit complex. We won't be covering it today, but the heat radiation via which the energy transfer from one place to another place does not require any kind of medium for transfer of energy from one energy store to another. We will discuss it in the future lectures, but not today. Okay. So let's just move toward the conduction, which I already mentioned that it's more common in the solids material. So before going to the solid, liquid, and gases or the transfer of energy across these materials, let's just have a quick look at how the particles, atoms, or molecules are packed or stacked in these in the matter. So if you look at solids, the atoms or molecules are usually very closely packed with each other, and they cannot get away from each other. Like they are not free to move like this. If this is the first particle, it cannot move all the way from here to here or all the way from here to here. But they still possess one kind of kinetic energy, that is they are vibrating around about their position. So if you zoom on one particle, there is some kind of space on the either side of the particle, and this particle keep vibrating in this space. If you're looking at the one direction, of course, if you're looking at this direction, it's also vibrating along this axis and along the z-axis. But for simplicity, we are just looking at the one axis, and when we look at it, it's keep vibrating. Now what happens is when you store in thermal energy from some source, like you are heating the object or providing energy from other source to thermal energy store of this particle, what happens? The thermal energy that is being provided to this particle is transferred to the kinetic energy store of this particle. And due to increase in the energy in kinetic energy store, the particle tries to start more with higher vibration, higher amplitude of vibration, and due to this vibration, it keep hitting its neighbors, like it keep colliding with its neighbor. And during each collision, a portion of its kinetic energy transfers from this particle to the neighboring particle with which it is colliding. And due to this transfer of energy, the surrounding particle gains certain energy, and it starts vibrating with higher vibration, and the process keeps on going. So that's how the conduction works in the solids, and that's how the particles are stacked inside the solid material. Okay, so if you look at the conduction, the energy is transferred from particle to another particle to particle to particle, and this mechanism keeps on going until all the particles have same kinetic energy in their kinetic energy stores. So thermal energy is stored in the form in kinetic energy stored in these particles, and if a solid rod is in contact with some kind of material, or it has air in its surrounding, and these particles now are vibrating here too, so they will transfer their energy to the surrounding or with whatever comes in contact with that material. So if you look at the conduction mechanism, let's say we have a number of people. So we got a number of people, and they got some items that need to be shifted from here to here. So what happens is when this person gets this item, it just transfers to this and picks the another item, and this person transfer it to another, and they keep shifting these particles from item from person to person, and that's how the items get here. So similarly, the energy is, if we imagine it's a block of energy, it keeps transferring from particle to particle. So in conduction, if we have a solid rod now, so we got the particle which are at higher temperature, and then we got the particles which are at lower temperature. So when we say higher temperature or heated particle, what we mean is these particles have more kinetic energy in their kinetic energy stores. And where did the kinetic energy come from? It comes from the thermal energy we provided to them. And this kinetic energy is transferring from particle to particle in this direction until all the particles are in thermal equilibrium, which by mean that all the particles have same kind of heat energy or same amount of kinetic energy in their kinetic energy stores. But what if we keep providing the heat energy from here, this end? What will happen? The energy will continuously get being transferred to these ends, but because this end is continuously receiving more energy in their kinetic energy store, so this will keep on heating. So this will be at higher temperature, this end, and this end will be at lower temperature as compared to this end, and this end will keep heating, but because this end has now a continuous source of energy receiving it, so this will be always higher at higher temperature, and this will be at lower. And if you look at it, the heat energy or energy from thermal energy is being transferred from high temperature to low temperature. So in conduction, we see that energy is always transferred from high temperature store to low temperature store. Okay, so that's how the conduction works in solid. Okay, so this was about one mechanism, that is conduction.